Hello and welcome to your Inelastic Collision Review. You have a quiz on this stuff tomorrow. Not expecting to be particularly difficult for you, but I wanted to go over everything with you one more time and do some example problems just to make sure. Alright, so you should have your notes out and following along in your notes. There should be literally nothing new. But you're going to follow along so that if I say something a different way so that it makes more sense, you can take down more notes. So first we're going to define what an inelastic collision is. Another way to describe this is a sticky collision. This means that when two things collide, they stick together and become one. So, let's see, how else do we want to say this? Two things collide and become one. Alright, now, this idea, in conjunction with the conservation of momentum, lets us solve all our problems. The conservation of momentum states that the total momentum before a crash must be equal to the total momentum after the crash. So let's say before the crash, car A has all the momentum, car B has no momentum. And after the crash, they each have 50% of the momentum. The total amount of momentum is the same, even though the momentum has moved from car A into car B. Alright, so let's state this mathematically. Total momentum before the crash, we're using this notation. Total momentum before the crash must equal total momentum after the crash, where the momentum equals mass times velocity of each thing. So this would be MA VA before the crash plus MB VB before the crash plus however many cars there are in this particular crash equals the total momentum after the crash. Now, since this is an inelastic collision, that means that they have come together to become one thing. They're one thing now. So they only have one mass, and since they're the same thing, they only got one velocity. Alright, this is your equation. Assuming you know your masses, I will give you two velocities, and you should be able to figure out how to solve for the third. It's just an algebra problem. The idea is that this is the momentum of A before the crash, and here's the momentum of B before the crash. Add those things together, and you get the total momentum before the crash. And this is the total momentum after the crash, because there's only one thing after the crash. Alright. An example. Ice skating is a great example. We have an ice skater skating for their very first time. Here are their ice skates. I know, it looks just like ice skates. We'll call this person A. Now, they're doing their own thing, not going very fast. They have a velocity, initial, of 2 meters per second. To the right. Alright, meanwhile, there's a hockey player practicing out on the ice. So, here we have our hockey player speeding along on his ice skates. Super cool. We're going to call him B. He is going this way with an initial velocity of much faster. To the left, he's going 5 meters per second. All right, let's also give ourselves some masses. Let's say that MA, that's going to be a 70 kilogram person. MB, this is going to be an 80 kilogram person to compensate for all of the extra muscle mass that a hockey player has. All right, this is before the crash. What happens next is they collide. Then we got this mass of people. So here we have person B and person A sort of combined together. Let's erase some of this other stuff. And this horrible mass. They've crashed, they've collided, their limbs have intertwined, and they're one thing now. And they go rushing off in this direction at some final velocity. My question is, what is that final velocity? All right. Let's find out. My equation states that MA times VA initial, the momentum of person A before the crash, plus the momentum of person B before the crash, must be equal to the momentum of person A and person B locked together after the crash. All right, well, I have all these numbers, right? So let's just plug them all in. Let's see, that's going to give me 70 times 2 plus 80 times negative 5. Let's slap a positive on that so that we don't forget. Equals 70 plus 80. The final. All right, now it's just a game of simplification. All right, 70 times positive 2, that would be positive 140. 80 times negative 5 is negative 400. 70 plus 80 is 150. All right, keep simplifying. We're not ready for algebra yet. Just keep simplifying. Positive 140 plus negative 400. Make sure you do this in your calculator to make sure you're getting the same answer as me. The correct answer here is negative 260 equals 150, the final. And now we are ready for algebra. You cannot do the algebra until everything is ready to go. Now that everything is simplified, you are ready to go. All right, we'll just bring that kind of along with us, I guess. Now I'll put it back. All right. Next problem. Or sorry, next piece of this problem, I should say. Algebra. What do? Well, that's multiplication. I need to get rid of 150 times VF. So I'm going to divide both sides by 150. Which gives me V final equals, let's see, negative 260 divided by 150 equals negative 1.7. 3 repeating meters per second. So the question was, How fast does the horrible mass of people travel after the collision? The answer is they are going to the left at 1.73 meters per second. All right. If there are any questions, please pause, rewind, watch that again more slowly. If there are still questions, ask me questions on the share stuff piece on Echo. All right. Now, I'm going to give you 3 examples. All of these are inelastic collisions. All right, all of them are inelastic. All right, first one, I'm going to give you MA, MB, VAI, VBI, and I want V final. That's just like the one we just did. All right, we're going to say 1,500 kilograms and 2,100 kilograms, going at a velocity of negative 10 meters per second, and going at a velocity of positive 5 meters per second. They collide inelastically. What is their final velocity? All right, next. Another inelastic collision. Again, it's 1,500 kilograms, but this time it's going to be 1,400 kilograms. I want to know, what is the initial velocity of car A, such that if car B starts from rest, the final velocity is positive 11 meters per second. And finally, MA is going to be 1,400 kilograms. MB is going to be, let's see, 2,100 kilograms. You know that VAI is negative 3 meters per second. You want to know what the initial velocity of car B is before that crash, such that the final velocity of the 2 cars smushed together is positive 3 meters per second. Interesting. All right. Please now pause the video, solve these 3 problems, and when you are done, press play again to check your answers. Ta-da! Here are the correct answers. So this one you solve exactly like we did the example problem I just walked you through. This one, first you got to solve for the final momentum. Realize that the final momentum equals to the initial momentum. Realize that car B has no momentum initially, so all of the final momentum is in car A. You divide out the mass, you get an answer. In this one, the hardest, first you need to find the final momentum. Then you need to find the momentum of car B, momentum car A before the crash. Subtract that out. Then divide by this mass to get this answer. Yep, I did that right. So, there we go. Notice the negatives and the positives. Those are important. Remember, negative means to the left, positive means to the right. All right. That right there is the end of your review. Your homework, according to my notes, is due tomorrow. There's also going to be a quiz. If you have questions, don't forget, the share stuff section. That is where you post questions about homework, about content, so on and so forth. All right, there we go. I'm done.